This second section's all about angles, and it's not really I don't think it's really challenging. It's just really conceptual. So you need to make sure you have a good understanding of this stuff, and if you do, you shouldn't have a problem with it. The first thing is just going to make sure you know how angles are drawn on a coordinate plane. So the x-axis, the positive x-axis is 0, and the graph will start here. Let me grab a pen. The graph will start here. Wow, I don't want to grab the same color because then you can't see it. So it starts here, and then depending on how big the angle is, it goes around in a counterclockwise motion like this. Then maybe it stops over here, and that tells you the size of the angle. So here this angle is probably about 150 degrees. So this is 90, 180, 270, 360. So you have to remember this counterclockwise motion. It starts here, so that's the initial side. Where it ends is called the terminal side. And that's all you need to know from this picture, pretty much. However, I should mention that this picture shows angles in degrees. And like I mentioned in the first video, there's more than one mode for angles. The mode that we always talk about is degrees, but in this section we're going to introduce something new called radians. But before we talk about radians, let's just do this really fast. It says, draw an angle with the given measured and standard position, so 240 degrees. It's asking you, what's the angle look like? So you know it starts at 0 degrees. It's going to go over to 180, and then it's 60 more than 180, so it's going to be somewhere down here. So this angle looks something like this. It starts here, that's the initial side, and the terminal side. Angle is something like that. The second one says 500 degrees, and that should tip you off right there that it's already larger than the graph because the graph's only 360 degrees. So it's going to have to go back around. It's going to go around 360 degrees, and then it's going to have 140 left. So it starts here, goes around 360, goes around another 90, and then stops somewhere here to get to 140 degrees. So this is a 500 degree angle, even though that sounds like complete nonsense. The last one's negative 50, and what that's just telling you is that it goes the opposite direction. Like it starts at 0, but then it goes 50 in the negative direction, so the clockwise direction. 50 somewhere down here, that's our angle, 50 degrees. Alright, this next problem, that's definitely in the practice problem set. I know because I have the practice problem set right here. It says, find one positive angle and one negative angle that are coterminal with negative 45 degrees and B 395 degrees. So coterminal is a fancy word to say the terminal side is the same as the one it wants. So this one, it says the terminal side is negative 45 degrees. You know that's somewhere right here because negative 45 degrees tells you to go in the other direction. It wants you to find one positive angle, one negative angle that's coterminal with that. So what we got to do is just start drawing pictures. We want to start with a positive angle. Positive angles go this way, and it has to stop right here to be coterminal with it. And we need to know how much that is. Well, it's 360 degrees. That is a 3. Minus 45 degrees, right? So a positive coterminal angle would be 315 degrees. Now a negative coterminal angle would have to be going in the negative direction, but it can't be the same angle, so we have to go here and keep going all the way around to 365. Then we get back here, so add another 45. 365 plus 45 to get 410 degrees. That would be a negative 410 degree angle. That would be coterminal with that. So here's our positive one, and here's our negative one. And I'm just going to do that first example for you. Alright, it's finally time to talk about radians, and it's pretty awesome. So here is the degree measure and radian measure circle, so you get an idea of what a radian is. So degrees go around like this, 0 to 90, 90 to 180, 180 to 270, 270 to 360. Radians are the same. It's just in degrees of pi instead of in actual degrees. So for example, 45 degrees is equal to pi over 4. That's a really important one. 90 degrees is pi over 2. 180 degrees is just pi. 270 degrees is, of course, 3 pi over 2. That's pi and additional 1/2 pi. And 360 degrees is 2 pi radians. Now, the rest of those are here for you. This is a circle. You definitely want to copy this down. I got this directly out of the textbook. I looked online everywhere, and actually the textbook has the clearest picture, so you can either copy it down from here or from the textbook. This is definitely something you want, though. That's a smoking tip right there. You're going to be needing that through this chapter and beyond. It's just good to start memorizing this stuff early. So what can we actually do with this? The first thing I want to point out is, just like I mentioned yesterday, make sure you know what mode your calculator is in. If you want to work with radians, put it in radians. If you want to work with degrees, put it in degrees. So let's just make sure we get it out of the way. Make sure you know what you're working with, degrees or radians, or else your calculator is going to give you some really bizarre answers, and it's not going to go well for you. Alright, so you've got that circle copied down. I hope you stopped the video and copied it down. Even if you can't, memorize the circle, some of those you certainly want to have memorized, but if you can't, or it's not in the circle, you can convert between degrees and radians. Once again, this is for your notebook, not mine. You can change degrees to radians and radians to degrees. To go from degrees to radians, you multiply the degree. So in the last chapter, we learned that a degree is theta times pi radians, and that's just written right here, over 180 degrees. And what that does is, this theta is in degrees, and this is in degrees, so it cancels out the degrees, and you're left with radians. Same thing over here, just opposite. If we have radians, we know it's in radians, and it's something, pi radians, whatever it is. We know radians have to do with pi, and degrees on top. It's going to cancel the radians, and we're going to get left with degrees. So let's go ahead and use that. We want to convert 125 degrees to radians. We're going to multiply that by pi radians over 180 degrees. And we're going to get, whatever 125 over 180 is, we're going to have to simplify that down, or we can use the calculator to find a fraction. Let's go ahead and do that as well, just so you guys have both answers ready. We have 125 divided by 180. We get 0.69444. If we want to convert that to a fraction, I'm going to press math, turn it into a fraction. So 25 over 36 pi radians. 25 over 36 pi radians. Remember from the circle that all the radians had pi in it somewhere? Except for 0, of course. That pi needs to be there. That's like how we show that it is in radians. Alright, this one's just backwards. You go from radians to degrees, we take that, we multiply it times pi radians over, or under, 180 degrees. Let's go ahead and multiply that out. We can use the calculator if we want. It's just 180 times pi on the top. So 180 pi. I made this all a little too big. 180 pi. And divided by 12. And our answer is going to be negative, or 12 pi, sorry. Because there's 180 pi on the top, 12 pi on the bottom. Our answer is going to be 148. Sorry guys, I made the classic mistake of not including parentheses. It's 180 pi on the top divided by 12 pi. We should get 15 is our answer in degrees. Now, if you don't want to go through those steps, sorry, grab the same color here. Then what you're going to do is just cross multiply. Pi's cancel out. What we have is 180 divided by 12 to get negative 15 degrees. It's the same answer. It's just you multiply the numerators across, you multiply the denominators across, make sure to divide them. Of course, you can cross multiply where you want. Just make sure you keep the negative sign, and you get negative 15 degrees is the same as negative pi over 12 radians. Alright, one more thing that needs to go in your notebook. It's about arc length and area of a sector. The arc length S and area A of a sector with radius r and central angle theta, measured in radians, are as follows. So if you want to find the arc length, this area on the outside, you're going to use S, arc length, equals r, the radius, times the central angle theta in radians. And if you want to find the area of this section, of this sector, that's area equals 1/2 radius squared times that central angle theta. Alright, let's say we have this problem. It says the radius is 18 meters and theta, that angle, is 25 degrees. And we want to find arc length S and area A, given the radius in theta. Now, before you go at this, you really need to put on the brakes because from that definition, it says theta needs to be in radians. So if we just try plugging this stuff in, we're not going to get the correct answer. We have to change theta to radians. And once again, that's 25 degrees times, the conversion is 180 degrees over pi radians. And that's going to give us, okay, 25 over 180. You know, we're just going to plug it in. I'm really bad at mental math, if you guys haven't realized by now. 0.138, change it to fraction, 5 over 36. So 5 over 36 pi radians. So our answer will be 18 times 5 over 36 pi. And it doesn't matter if that pi is out front or on top, it's the same exact thing. Arc length is going to be 18 times 5 over 36. 18 times 5 pi divided by 36, 7.85, and that will be in meters. To find the area, we just do 1/2 radius squared, so 18 squared, times theta. We already changed it to radians, so we don't need to do it again. 5 pi over 36. Multiply all of those together to get your answer. What is the area of that sector? So 0.5 for 1/2 times 18 squared times, all right, 5 pi, and then divided by 36. And I'm going to go ahead and include that all in one set of parentheses, 5 pi divided by 36. So our area is 70.685. And that's in meters squared.